Hello and welcome to TelecomTV. We're on tour. We're in the United States, in San Francisco at the Moscone Center in downtown at the IDF 2014, which is the Intel Developer Forum. And I'm talking with Kelly Herrell, who is VP and General Manager, Software Networking Business Unit at Brocade. Kelly, welcome. We're at the show here, the IDF 2014. There are 5,000 some odd developers here, yes. And some of them are a little odd, but they're enjoying themselves. There's quite a lot of noise, there's singing, dancing, who knows what else, people making robots. We're sat over here being serious, comparatively, okay? And I'd like to begin by asking you a sort of general question. How do you think SDN and NFV are actually transforming the networking industry right now?
That's a big question, a very relevant one. I think actually the best way to answer it is to back up a little bit and look at what is happening to the environment that would cause SDN and NFV to come into play to begin with. Traditional networking, legacy networking, was really designed and optimized around the legacy compute model and a lot of almost legacy business models. And what's been happening now in the environment that we're in really bears no resemblance to the environment that was present at the time that the legacy infrastructure was being designed. So today we have new things that are transforming the overall environment and the landscape. We have things like cloud, we've got big data, Internet of Things. I know IDC has referred to a bunch of these, put them together with mobility and called the need for the third platform. And that's a general statement for technology. But what this is doing from the network standpoint is it's really ushering a new era of the new IP, where the old IP was really designed for the legacy environment, the new IP is really designed for this new environment. So when you look at things like SDN and NFV, these are prime examples of the new IP. And the way that transforming the network is in some very profound ways. There are the fundamentals, what it's doing to transform the economics, which is to really radically improve the efficiency per dollar expended. But more importantly is what it's doing to transform the agility of the network. So the network is not this ball and chain that is very immobile and inflexible. Instead, what you've got is, by decoupling hardware from the software and moving away from the traditional black box model of network devices and moving into a world of networking that is really heavily influenced and powered by software, which has, through the power of decoupling and the power of the IA architecture underneath, has been able to produce profound opportunities and new ways to think about how to provision and how to deploy networking. If you look at the traditional model, just a good example actually would be with telecom service providers. You know, one of the great egregious examples of inefficiency is this thing called customer premise equipment. You know, the service provider's business model is to derive customer subscription revenues. Well, to do that, they have to get them connected. So the thing that's in the way of them monetizing their entire business model is that endpoint of connectivity. Well, what if you could actually take that functionality and, instead of deploying it at the edge, what if you could deploy it in your data center virtually, software on top of Intel servers, and use all of the orchestration types of and virtualization capabilities that are inherent in data centers, from the most modern of data centers, from the Googles and the Facebooks that have entirely modern infrastructure built this way. What if you could do that from a services perspective, network services perspective? That's just an example of how NFV is beginning to transform the landscape. And then SDN is one level above that, an abstraction layer, which gives you the abstracted control, because really you can't get rid of complexity. Complexity is always going to be there. You can tame it. And the way you tame it is by inserting SDN control on top of that and letting the controller handle the complexity while the customer focuses on the value add above it, the manipulation of the network itself. So all of these things are coming together. SDN and NFV are very commonly used together. I like to think sometimes that NFV is a killer app for SDN.
That's a really good comprehensive answer. one of the best I've ever heard. Very good.
I'm glad to hear it.
Well, let's move on. What about Brocade? What is Brocade's SDN and NFV vision? And given what you've just been saying, where are you going to go with it?
So Brocade is very, very committed to the software direction as a complement to hardware networking, and it is complementary. But not that many vendors are actually heavily committed into the software element of it yet, because the software runs the risk of actually cannibalizing their hardware business. And Brocade doesn't have this concern. So Brocade actually is very aggressively investing in the NFV space and the SDN space. And specifically from a network capability standpoint, in the OSI stack, we have layer 2 through 7, a full suite of layer 2 through 7 virtualized infrastructure, optimized for Intel, deployed today. We also have an Open Daylight SDN controller. Open source plays a big part in this new world as well. And then that controller speaks northbound to open orchestration environments like OpenStack. So we see in the software space, we see this 3-layer cake of services, control, and orchestration, all based on open standards, a lot of open source, and open interoperability.
Why is it, do you think, in this occasion, we've all seen allegedly open initiatives in the past, and usually they've been stopped in the tracks by proprietary equipment ideas, whatever it may be. Yeah. There seems to be this time around, there seems to be a really heavy momentum behind it being open. Why? What's the difference this time?
Control over, the customer needs control over their destiny. And there's a class of customers, the world's largest IT buyers, the big telcos, who must necessarily progress their infrastructure. If you're in the business of selling your network, you can't get it modern fast enough. And that means software, it means Intel servers, it means this openness and this control over their own destiny. And so they're insisting on it. It really, it's like you say, the concept of openness, whether it's open source, open standards, what have you, it's been around for a while, but actually what open is, open's not an attribute, open is an environment. You know, it's like freedom. You know, freedom is not one thing, it's a collection of many things. You know, freedom of speech, freedom of religion, all the different things, which individually could be challenged on their merit, but collectively end up producing basically an environment free of tyranny. And openness is the same thing, open source, open standards, many different attributes, but collectively create an environment of freedom and control over destiny. So what you're seeing now is you're seeing large customers telling the vendors that this is what we demand. We are no longer going to be trapped in a black box lock-in model. We must have control over our own destiny, and that is translated as open.
Excellent. Let's get a bit more nitty-gritty of the technology. Tell us something about Brocade's virtual appliance portfolio. What do you actually make, and what do you actually sell?
Sure. So Brocade has at the foundation our virtual router, which has IP routing, firewall, VPN, NAT, a whole bunch of layer 3+ services. On top of that, virtual load balancer as well. So everything in the layer 3 all the way up through layer 7, and highly optimized for Intel architectures. You hear the phrase DPDK used. We've been optimized on DPDK from the beginning. We're getting outstanding performance from that. Very recently, often the vendor likes to tout what they're achieving, but just recently Telefonica actually published performance marks that they achieved using Brocade's virtual router and Intel servers, where they went from a thumb drive with the software on it to a completed test and pushed 80 gigabits per second through an Intel server using a virtual router. So 80 gigabits per second in the proprietary black box world is somewhere, it's a 6-digit box, $100,000, $200,000 potentially. And we're saying we did this on a server. This is what Telefonica said. So the first part of the Brocade portfolio that's important to understand is not just that we have the network services, again, routing, firewalling, VPN, load balancing, but it's that we have them at tremendous performance differential because it's been optimized for Intel just from the beginning. And we have down on the show floor a number of demos. I can't even count how many demos there are down there that are showcasing Brocade's software. But as just one example, there's one of them that is configured that has a routing table of about 10 million routes, which is the equivalent of about 20 internets. And that's being conducted in a virtual machine in a data center somewhere, remotely. Back to the point, remotely, right? It doesn't have to be here. Right. The concept of cloud and physical presence is not necessarily, for the first time, tied to where the service is being conducted. So, so that layer of service is highly optimized for Intel. And then the control layer on top of that, SDN control, those are the core components of the Brocade software portfolio and are really key elements of the new IP.
Now you're in collaboration partnership with Intel, and you have this thing, the Vyatta Reuter, which I believe you've been talking about to some extent. What do you think are the specific benefits that you get from deploying the Reuter on the Intel architecture-based system?
Depends on what you want to do with it, and that's the beauty. That's the beauty of the software networking model. Do you want to use it for a high-performance, low-cost aggregation device? If you do, you know how to fit that in your topology. But what if you want to rewrite the rules of the way that you deploy networking? Going back to the telecom example and the customer premise equipment. Instead of subscriber infrastructure out at the edge, what if you wanted to build a subscriber cloud? So instead of one very powerful virtual router, what if you wanted to multiply virtual routers in a single piece of hardware in order to lower your cost per subscriber? And that's the most interesting thing. There's two ways to view how you wield this technology according to your business goals. One, the sheer performance is eye-opening, but sometimes the implications, the business model is actually won over the sheer performance. If I can fit 40 virtual routers in a single server, what is that doing to my overall cost model? And if I can actually deploy them with the push of a button and deprovision them or move them, what are the implications to the way that I manage my network and the costs associated with that? So it really does depend on what you want to do, and that's why I say it's so important that this movement that the software has decoupled from the hardware in networking. And this has happened before. This happened in even bigger industries. The compute industry went through the open systems revolution in the late 80s, right, and early 90s. And the mainframe model, that black box, which came with its own proprietary software, and only was provisioned and allowed that way, succumbed to a model where the software decoupled from the hardware, and innovation ran amok. And there were two models to that. One was Unix on RISC processors, like a Spark processor, and then what happened after that was Linux on Intel architecture. Well, you can see how that played out. Right, and so the same, we believe exactly the same thing is happening right now, and Intel is proving it with the continued improvements in the IA architecture. I roughly calculated the other day that in the past 4 years, Brocade's software performance has improved 1,000x in 4 years. That's the software on a stock Intel server. So, you know, that price performance curve and that attack vector has never existed before in networking.
Interesting you say that. I was going to ask you as a final question what the benefits you get from being in collaboration partnership with Intel. You just specified that. What's it like working with them?
It's really rewarding, I have to say. I've had the pleasure of working with Intel in a former life as well. And the thing that is so valuable about working with Intel is that the company has a long-term strategy, and it doesn't get nervous or deviate. You know? And so an old friend of mine said, never bet against the world's largest semiconductor company. Well, in general, the idea that networking is becoming another workload on x86, that is a venerable position to have the opportunity to partner with.
Sure. And
so our relationship with Intel goes back 7 years. So we've been working with Intel for 7 years on optimizing software for the x86 environment, which is why Brocade is widely recognized as being so far ahead.
Okay. Interesting stuff. Thank you for it. Kelly Herrell, thanks very much.
Thank you.